Hi, hello, this is Joanne Califano, and I'm talking to you today on May 18th, the beginning of week 6 in our course. So, on this date in our calendar, my expectation is that you've worked through most of the modules or homework lessons on decimals, and today's lesson 3.6 is on decimal percent and application problems. And I just wanted to make a little video for you about these decimals and percents and working on those. So first of all, you saw in the textbook itself link that there are these pages here that talk about decimals and reading decimals. So a decimal point right here separates our whole numbers from our fractions or decimals. Decimals are fractions really. They're all fractions that are always in tenths, so a tenth of something. And when we pronounce a number like 1,357 and 924, we always say the place value of the last place in that number. And this is tenths, hundredths, thousandths. So we would say thousands. We would read this number 1,357 and 924 thousandths. And we always use a THS at the end of that word so we know the difference between a thousand and thousandths. Okay. Not every culture uses a decimal point for a decimal. I know that there are some cultures that use a fraction. I mean, a comma. Sorry, a comma instead of a decimal point. So you will see if you look at foreign currencies and foreign currency exchanges, you'll see decimal point. I mean, comma in the place of the decimal point. But we in our culture use comma just to kind of help read numbers that are larger than the thousand place. So it is quite, this is the formal way we write a number like 3,564 and 31 hundredths. And we use a comma between the thousands set of numbers and the hundreds. But a lot of places you won't see people bothering with the comma if they're just writing 3,564 and 31 hundredths, or if this were money, right? You would not often see that comma there. Sometimes it's there, sometimes it's not. It becomes more used when we have numbers that are greater than the thousands place. Like this is 11,349. We would put a comma there. And 302 thousandths. That's the thousandths place. We say the name of the place that's there. All right, so that's reading some of those numbers and what's common and not so common. I wanted to take a look at, and I have to move this over, sorry. I wanted to take a look at adding and subtracting real quick before I go on to percents. Add, subtract, multiply, divide. What are the operations that we do with our decimals? And you've gone through these video lessons, I'm sure, already, but I just want to put my 2 cents in there. When we're adding and subtracting with decimals, you always line up your problems on the decimal point. So I would write the 605 and 42 hundredths if I were adding that to 1,032 and 308 thousandths. I would want to line up those numbers on the decimal point, and that makes all the numbers line up on their place value, the ones, the tens, the hundreds, and the hundredths. And there's no digit here after the 42, but you can always put an extra 0 after any number that's to the right of the decimal point. And it doesn't change the value. It doesn't move that 4 and that 2 out of its place, but it's a placeholder. And then we would add those numbers. 8, 2 is 7, 5 and 2 is 7, 3, 6, 1, and we'd get our answer that way. So we're always lining them up on the decimal point. You have to be a little more careful with our subtraction problems. So our subtraction problems, I might need a little more space for these. Let me space this out on the page here. Our decimal points, again, are lined up the same way. We have 19,504 subtract 2.03. Now when I'm doing this by hand, again, we can add an extra 0 here. In this particular place, it doesn't really matter. 4 take away nothing is a 4. Okay, but it might matter if I have to put the placeholder in the part that's in the first number, and I'll see that in a minute too. So let's subtract 0 minus 3. Of course, we'd have to borrow now from the 5 and then add a 1 there. So now that's a 10 minus 3 is a 7. 4 minus nothing is a 4. And then 19 minus 2. That's how we'd get that answer there. So again, line them up on the decimal point. I'm going to need a little more space here for this one. Oops. I've got things overlapped here. Sorry. So this problem right here, let me see what other color pens do I have. Okay. This problem right here, I would write 35 and 219 thousandths, subtract 8, and now we have 5302, or basically 5,302 tenths, hundreds, thousands, 10 thousandths place. That would be, right, if I were reading that number. We have to be real careful. We only use the word and officially when there's a decimal point. A lot of people like to say 305 or 302 when you're talking about a whole number like that, but we really don't use the and. They're not supposed to use the and when we're just saying the number 302, but we tend to. Officially, the decimal point is where you put the and when you're speaking the word. So anyway, let me do this subtraction. Now notice here, there's nothing above the 2. We do need to put in a 0 there to make sure that we are seeing that as a 0. And we're saying 0 take away 2. Of course, you can't do that. So we have to borrow from the 9. And the one that we're borrowing from the 9 gets put next to that 0. So that's really 10. Take away 2 is 8. 8 take away nothing is 8. 1 take away 3. Again, we have to borrow. It's really 11 take away 3. I think that's 8. 8, yep. And again, I have to borrow. I have to borrow from the 5, make it a 4, and add a 1 here. 11 take away 5 is 6. And 8, again, I have to borrow. Man, the 1 I borrow, I put there. 8 from 14 is a 6. And then 2 take away nothing is a 2. So there's our answer right there. A lot of borrowing going on. And that's, again, what happens when we're subtracting, whether it's decimals or whole numbers. We have to borrow quite often. And let me just look at this one right here. If we have 1 minus 0.034 or 1 minus 34 thousandths, I have to double check all the time before I say it. Okay, I'm going to set this 1 up with 3 zeros after the decimal point because I need to subtract and line them up, and what I'm subtracting is 0, 3, 4. So we have to line them up, give extra zeros after the 1 in order to do that subtraction. 1 take away anything is going to be a decimal answer, no whole numbers at all. So we know our answer is going to be 0 point something just from looking at the problem. So 0 point what? So here I'm going to, like I said, put 3 zeros. 4, I have to borrow, nothing to borrow from, nothing to borrow from, but to go all the way over here to the 1, make that a 0, and we're borrowing now. That becomes a 10. Borrowing from the 10 makes it a 9. That becomes a 10. Borrowing from that 10 becomes a 9. Make that a 10. There we go. A lot of borrowing went on there. So really this number is saying 9 tenths, 9 hundredths, and 10 in the thousandths place. And of course that makes it a really awkward looking number. If I were to write it like that, I couldn't because of the place value system, but we have to borrow and end up with that to do our subtraction. So 10 take away 4 is a 6. 9 take away 3 is a 6. 9 take away nothing is a 9. And there's our answer, 0.996. Okay. So a little tricky, little artwork there going on, really, when we're doing our subtraction. And we have to be careful. Now, when we are dividing and multiplying, we're going to look at multiplying first. and then I'll look at division, and then we're going to get to our percents. This might be a long video, but you can always pause and come back to it later. And if you miss something, you back up. So I just want to make sure it's all in here, that we know how to add, subtract, multiply, and divide with our decimals. And then we'll take a look at our percent problems and the application problems also. So I need to make a little bit more room here. Whoop. I'm going to move this down also. Now it's running over top of each other. All right, just going to come back up here for a minute, and I'll finish moving things around when I'm done. All right, multiplying. We don't line up our numbers on the decimal when we're multiplying. We can just stack them like we're multiplying every other kind of whole number. All right, stack them. 75.12 times, I have 2013, but the decimal belongs here. Okay. Once I set up my numbers and I stack them like that for multiplying, I count how many digits are after the decimal point in all of the numbers I'm multiplying. So I've got 1, 2 places to the right of the decimal here, 1, 2, 3 more places to the right of decimal here. There are 6 places to the right of the decimal. So because there are 6 places to the right of the decimal, I'm going to move this over 6 places down here at the bottom. So right now I'm just going to let that hang there for a minute until I do my multiplication. And a lot of multiplication going on here. Let's get our numbers. 3 times 2 is 6. There we go. 3 times 1 is 3. 3 times 5 is 15. Carry the 1. 7 times 3, 27, 28. After I add the 1. No, I'm sorry, 21. I did it wrong. I've got too many things going on right now. I did it wrong. See? Sometimes we do it wrong. And I do too. So, in other words, 3 times 1 was 3. 3 times 5 is 15. Carry the 1. 7 times 3 is 21. Plus 1 is 22. Thank you. I know you were thinking that, and your thought vibes got back to me, and I corrected my problem. I think I did. Okay, 1. Let's multiply this 1 times 2. And of course I put it right here. 1 times 1. 1 times 5. 1 times 7. And this 0, well, 0 times anything is 0, so I don't have to put anything under that. But now I multiply by this 2. So everything, all my answers start underneath this 2. 2 times 2 is 4. 2 times 1 is 2. 2 times 5 is 10. Carry the 1. 2 times 7, 14. 1 more is 15. Okay, add them all up. We have a 6. We have 3 plus 2. We're adding now. 5. 5 plus 1 is 6. 5, 9, 10, 11. Carry the 1. 7, 8, 9, 10, 11, 12. Carry the 1. 5. 1. So I said 6 places is what we have to move our decimal. Let's drop it down here and then move it 6 places. 1, 2, 3, 4, 5, 6. So here's our answer. 15 and 121,656 hundred thousandths, tenths, I have to count over tenths, hundreds, thousandths, 10 thousandths, 100 thousandths, millionths. This is millionths, isn't it? I had to double check that myself. Okay, so that's your answer. You can always, that can't be the right answer, can it? 75 times 2 is 150. Our decimal belongs there. What did I do wrong? I counted wrong. I'll have to redo this whole thing. 1, 2, 3, 4, 5. There's 5 places after the decimal, Joanne. Oh my goodness. Double checking. So what I did here, and this is a good skill too, is I estimated my answer. If I am estimating, I am multiplying 75 times 2. 75 times 2 gives me about 150. So when I looked at my answer, I said, oh, that's not near 150. Put my number back here. So I have to have at least 151 would be closer to 150 than 15. So that there would be the better answer. And I looked back to see what did I do wrong. I counted wrong up here. 1, 2, 3, 4, 5. 5 places. Drop down here, move the decimal 1, 2, 3, 4, 5 places. And that is where it goes. 151 and 21,656 hundred thousandths. I hope you hear me. Let me see. I'm going to move on to another problem. Okay, so estimation skills, really good way to make sure you got the right answer. For example, 3 times 15, I would guess that my answer, just ignoring what comes after the decimal point, 3 times 15 is 45. So it needs to be around a 45. If I get 4 point something, can't be right. If I get 450, that can't be right. So about 45, I would stack these with the total, the 15.2 first times 3. That just makes the multiplication easier. 3 times 2 is 6. 3 times 5 is 15. 3 plus 1 more is 4. And then I check my decimal point. I only have one place after the decimal here. Drop down here, move it over one place, and 45.6 is your answer there. Okay, good answer. And I'd just like you to take a look again at the number of places after the decimal. We know 3 times 2 is 6, but neither of these are whole numbers. So we will get a much smaller number than what we see there, won't we? So I'm going to give myself a little more space here. 0.03 times 0.02. 1, 2, 3, 4 places after the decimal. So we do our 3 times 2 and get 6. And we drop down here and we say move it over 4 places. 1, 2, 3, 4. 4 places over gives us the number 0.0006, or in other words 6 tenths, hundredths, thousandths, 10 thousandths, 6 10,000ths. For our answer there. And 0.4 times 0.4, my son likes to tell me that's 16. It's 16, yeah, 4 times 4 is 16, but where does the decimal go? So 0.4 squared, or 0.4 times 0.4, again, you have 2 numbers after the decimal point here, 2 places after the decimal, or to the right of the decimal. So we write our answer, 4 times 4 is 16, and we know we need to go 2 places over. So it will be 0.16, or 16 hundredths. 3 squared means 3. 0.3 squared means 0.3 times 0.3. 2 places after the decimal. So 0.3 times 0.3. My son likes to think it's 0.9. Is that right? It looks nice, doesn't it? It looks nice that way, but that's not following the rule. So actually, no. That's not 0.9 because we have a total of 2 places after the decimal here. So we'll write our answer as 3 times 3 is 9, but we need 2 places after the decimal. So we need to go over 2 places, 0.09. So 0.3 times 0.3 is 0.09, 9 hundredths. That's right. Okay, so division. Now, how we multiply things is an algorithm. I'm using the stacking algorithm for my multiplication. In many schools, they teach a grid method, a totally different method. So you might see young children doing this in a totally different way, because that's how their textbook or their teacher wants to show them how to multiply, and that's okay. There are a lot of different ways to do the long division and the long multiplication. So I wanted to make some division problems here, but I'm afraid I couldn't find on my calculator on my computer. I couldn't find a division symbol, so I'm going to kind of rewrite them like that to do this division. So if we were dividing decimal numbers and the divisor is a decimal number, the algorithm that I've always used tells me to take the number 0.06 and dividing into 0.378. My algorithm says move that decimal over until you have a whole number. So I'm going to move my decimal over 2 places in my divisor and then match that. Do this little 2-step dance, right? We're going to do this 2-step dance here and move it 2 places over here in the dividend. In what we are dividing is called the dividend. And from there, we're going to bring it right up, like bubbles in soda, make it rise right up there. So basically, I'm changing the problem from 0.378 divided by 0.06 into a new problem, which is 37.8, just plain old 37.8 divided by plain old 6. It will give me the same answer to do this problem than the original problem. And it will keep my decimal point in a nice place. So 6 into 37 goes 6 times. Maybe I should do it down here as I rewrote it. And then I do short division actually. In my short division, it's like long division, but it's short. In my short division, 6 times 6, 36. Oops, 36. I'm subtracting. I know I get a 1 left over, so I'm just going to put my 1 here. And then just one time, 6 goes into 1. No. Well, now I'm going into 18, right? Let me do long division. I'm going to confuse myself. Let me write this all down. 6 times 6, 36. Subtract brings you 1. Bring down the 8. And then 6 into 18 goes 3 times. And there's my answer right there. So 6.3 is your answer. Okay. And move on to the next problem. 1.05 divided into 3.15. Okay, long division. We could move this decimal over 2 places to make it 105. Do the same thing in my dividend and then bring it up in my answer. 105 into 315 actually goes 3 times. And that's it. There's your answer. Okay. And then my last problem, 0.05 into 200. That's like saying how many nickels are in $200? How many nickels are in $200? So I would take the decimal point. The algorithm says move it over 2 places in the divisor and do the same thing in the dividend. There was no decimal point, so I'm going to add it. And if I know, in order to move it over 2 places, I need to have 2 more zeros here. So I bring it over here and then bring it up in my answer. And then I'm just dividing 5 into 20, which goes 4 times. Into 0 goes 0 times. Into 0 goes 0 times. Into 0 goes 0 times. There are 4,000 nickels in $200. That's what that is telling me. You can always double check that. All division problems you can double check. Take that answer, multiply it by 0.05, and see what you get. 5, 5, 5, 20. 2 places after the decimal, right? Move it over 2 places here, and you get a 200 as an answer, and that's exactly what we started with. So we have that correct. This is my check. It's good to check your work. Checking means do everything in reverse order sometimes, right? All right, now moving on to percents. So percents can be seen as fractions and decimals. A percent literally means out of 100. Oops, I didn't mean to cross that out. It means out of 100. So you could always think of your percent sign as being, you see how the percent sign looks like that, right? So if I said 6%, it really means 6 out of 100. That 100 is right here. 6 out of 100. That's what percent means, out of 100. 6 hundredths. I think of it this way. If I have 6 hundredths as my fraction, I can write 6 hundredths in a decimal by putting the 6 in the hundredths place. So 6%, 6 hundredths is written as 6 hundredths the decimal. Okay? Percent means hundredths. If you had 2% milk, right? 2% milk, that's 2 parts per hundred fat. And that is 0 point. I want the 2 in the hundredths place. 2 hundredths. There's your decimal equivalent of a percent. Okay. There are 2 different ways to work out percent problems. There's a ratio method, and then there's the algebraic method. Those are the 2 main methods that I like to teach. I think the textbook was going to a different kind of multiplication. I thought it was a little confusing. I like to go back to my percent, either decimal method or my ratio method. Choose one or the other. If you choose the ratio method, you're always putting your percent in a fraction, 15 over 100, and then your portion over your total in your other fraction. Okay. So if I were to ask, 15%, well, I'm not asking any questions here. Everything's filled out. 15% is 15 out of 100. That is 15%. This is another way of writing. 15% of 100 is 15. If you had a $100 bill and you wanted to leave 15% tip, you would have 15% of 100 is $15. Is $15. This is the algebraic method. In the algebraic method, we use times for of and equals for is. So 15% of 100 or times 100 equals 15 would be another way to write that percentage problem. Okay, so let's try a couple different ways. For example, a textbook is sold for $48. If this cost is increased by 14%, what is the new cost? The new cost of the textbook. Let me make sure I have enough room here for my word problems. Oop. Okay. Whoa. Oh, this word problem's out of place. I'm sorry. Let me move it over here. Okay. I didn't talk about the different ways to do those problems yet, and then this word problem popped in. So again, I don't have this in the right place. I'm going to actually move this down below. These are the problems. Okay, so that we can look at this one at a time. Percent has 2 methods, proportion or ratio method, and then algebraic method. So let me show you different ways to do that. Find 30% of $900. The equation method or algebraic method says find 30%. 30% can be written as 0.30 is in the decimal form, and of means multiply. And that would be your problem right there. 30% of 900, multiply those numbers, okay? 900 times 0.3. I don't need that extra 0. I can save myself a little ink here. And I want to move my decimal 1 place now. 270 would be my answer. Multiplication method. The other method, the ratio method, would say, if I want to set this up as a ratio, I think it's a fun method. I would take my 30% and I would write it as a fraction. And I would set it equal to, and then I would want to figure out, well, set equal to what? I need one more fraction on the other side. What should it look like? Well, it's going to be portion out of the total. Find 15% of $900. That of number goes on the bottom. $900. What is that number? So ratio method, I would set this up like a ratio proportion where one fraction equals another. I would cross multiply, and I would get 30 times 900 equals 100n. And I would multiply those. I'd end up with 3 zeros, 27 here. And then I would say to find n, let's divide both sides by 100. That divides by 100, gives me 270 as my answer. That's a method that I like to teach people who like that ratio method. I would go that way. So we have equation method here, multiply straight out, ratio method, set them up in ratios, cross multiply, divide to get n, to get your answer. So you can choose which method you like, which one you're familiar with, which one makes you feel more comfortable, and set them up like that all the time. Now there's different kinds, 3 different things you're going to look for in proportion problems. One is your answer. 30% of something is your answer. Boom, straight up to multiply. The other one is the percent itself might be missing. What percent is 40 out of 120? Ratio method would say, what percent, that's what I'm looking for, n percent, equals my is out of my total of. Is over the of, 40 is my is number, of is 120. Let's set it up that way. That would help you find your answer. Cross multiply. And then to get your answer, you're going to end up having to divide by 120. And that would be the math you would have to do there. 4,000 divided by 120. I can knock off 1 0 top and bottom. Becomes 400 divided by 12. I still have to do that math though, don't I? Gives me 33. Looks like I'm going to have a repeat going on here. Add a 0, bring it down. So it looks like it's going to be 33 1/3%. Whenever that 0.3 repeats, it really is the fraction 1/3. You don't need a decimal point there. Okay, so that's your percent that you're looking for. What is my percent answer? Decimal there. And then the other thing is you have the of number missing. 25 is 10% of what number? 10% is your ratio, if you want to do ratio method, equals the is over the of. Of is missing. So 10% of what number is 25? It would go like that. Cross multiply. And divide. To get your answer that way. Writing it out in an equation for this one right here. I like ratio when I'm trying to find the percent, but this one has the percent. You could write this equation as 10% in decimal form of what number? I don't know. Is 25, and set it up like that. I would still have to divide both sides by 0.10 then. So it would be 0.10 into 25. So I don't need that 0, do I? We don't need that 0. So 0.10 is the same as 0.1. Give me my eraser. 0.1 0.10, right, is the same as 0.1. So you really have 0.1 into 25. Move your decimal one place. Move your decimal one place. Bring it up. 1 into 250 goes 250 times. So again, I get that answer of 250. Two different methods. But some of our word problems are a little bit different, and really require us to think about where we're going with this. Oops, I'll move this word problem down without the ink. There we go. So I'd like to look at some of these word problems. Let's see, I'm going to move this one down. And move this one down, up. All right. Okay, so kind of put on a shopping mind now. When we're gonna, we use percents quite often in the real world with shopping and taxes and discounts. So let's get some discount problems. If I bought a dog trimmer tool for $18 and it was on sale, it was 20% off. What was the original price? This kind of problem here. Quite often we like to take, let's just multiply what we see and multiply 20% times 18. But percent is a very particular kind of problem. In this case, if we don't know the original price and we want to subtract 20% of the original price to get my discount, but I don't know the original price. So 20% of 18 is not the same number as 20% of the original price, right? If I gave you 20% of $10 and I gave someone else 20% of $1,000, who would get more money? They would not be the same amounts of money. If you're not multiplying the 20% times the same number, it'll give you a different amount. So we don't know the original price. We can't multiply 20% times 18. That's not the right value. That's not the original amount. So this is what I'd like you to think of. If you're going shopping for something and you see a sign that says 20% off today, off of the original price, instead of thinking about how much you're taking off the original price, think about what that is, what's remaining. If you're taking 20% off the original price, that means you are paying 80% of the original price. Now, it doesn't look like such a nice ad when they say only pay 80% today. It doesn't quite catch your eye. That's why when they talk about how much they're going to take off, they like to use that in their ad instead of how much you're going to pay. But when your price tag is 20% off, you are paying 80%. Now, let's put that idea into this problem. You're paying 80%, I'll put it in decimal form, of the original price, which is what we're trying to find. 80% of the original price is what you've paid, is the $18, or what I paid. Okay? So instead of taking 20% off, we can't, because we don't know what we're multiplying 20% of. We are going to multiply the original price times 80%, and that should equal what the discount is today. So 80% of the original price is 18. There's an equation we can work with. If we want the original price now, divide both sides by 0.80, and you'll get your answer. The original price. Okay, at this point, we practiced all our multiplications and divisions. So I'm going to actually go to my calculator now and say $18 divide by 0.8 gives me $22.50. That was the original price. If you're not sure, take the $22.50, multiply it by, well, you can go ahead and multiply it by 20% and subtract it from $22.50 if you want. But that's a two-step problem. I'd rather say $22.50 times 80% is my discounted price of $18, and that would be my check, to check the problem, to check my work. Okay? If my salary increases in June by 18%, what will my new salary be? Oh, these are in a different order. I wanted to do a different order because this problem is supposed to follow the other problem. Isn't that funny? They're out of order now. All right, let's see if I can capture that problem and move it down. Okay. Okay. I'll move it down here. We'll get back to it. All right. I wanted to look at a textbook sold for $48. So let's look at this textbook selling for $48. If this cost is increased by 14%, what is the new cost? Now, if you could say, let's take the 48%, $48, multiply it by 14%, get my answer, right? And then that would be the increase amount, but the new cost would be that $48 plus my answer, and that would be my new cost. Okay, now that's 2 steps right there. What I want to show you is a one-step way to do this. One step. If a textbook sells for $48, the cost is increased by 14%. When I'm done, I'm not just going to pay 14%, I'm going to pay one whole amount plus 14%. So I'm going to multiply this by one whole amount plus 14%. Try that problem right there. Do this. You can do it in 2 steps and then try it in 1 step. $48 times 1.14, and I get my cost in one calculation. $54.72 is my new cost of the textbook. Increased by 14%. Increased that one price by 14%. I think some of these concepts were covered in those videos you watched, right? In word problems. If my salary of $20,000 is decreased by 15% due to COVID-19, what's my new salary? So that means I'm taking away from one whole amount. So from one whole salary, I'm taking away 15%. In other words, from 100% of my original salary, I'm taking away 15%. Just looking at the percentages, 100 minus 15% is 85%. I can find my new salary then by taking 20,000 and multiplying it by 85%. That will show a decrease of 15%. So multiply that by 0.85. I didn't plug it in right. And I get a new salary of 17,000. It's just like saying find 15% of my salary, 15% of 20,000 is 3,000. Subtracting it from my original salary gives me 17,000. That works too, but I'm showing you a one-step method. Subtract the percentages first. Multiply the amount of your money times the percentage, which is less than 100. Less than 100% is a decrease. More than 100% is an increase. So the first problem I did here, if I'm increasing by 14%, I'm adding 14% to 1, and that's my multiplier. If I'm decreasing my salary, I'm subtracting 15% from 100%, and that's my multiplier. Okay, now I got this last problem. If my salary increases in June, so this salary I have here, this 17,000 increases in June by 18%, someone might say, hey, that's awesome. You might have lost 15%, but now you're gaining 18%. Wow, you're going to be making so much more money. Aha. So we're going to multiply this by not just the 18%, but by 1 plus 18%, 1 plus 18%. And then let's see what that new salary will be. 17,000 times 1.18%. Wow. Oh gosh, wait, hold on. I'm only making 20,060. Why? Why is it only that much money? Well, because your 18% now is not on 20,000, but it's on 17,000. So even though the percentage is much higher than 15% that I lost in the last problem, it's on a different amount. So it's not as much of an increase as you might expect. So what you're multiplying your percent by is an important thing, right? It's important. Okay. A couple different application problems you might see in the homework or in the practice test, actually. A woman making $32,000 a year receives a cost of living increase of 2.7%. What will her new salary be? She'll be making 100% of her old salary plus 2.7% of her new salary. So it's going to be 102.7% is what she's going to be making times her original salary. So 32,000, right? Times. Now we have to put this in decimal form. Move your decimal over 2 places. In other words, if 102, this is harder when it's over 100, isn't it? 102.7%. If you want to turn it into a decimal, you move this decimal over 2 places. So it's 1.027 is the decimal multiplier to get that answer. Okay? So multiply that to get your answer. So her new salary, well, I'll let you finish that problem. But I want to look at this one. Kara categorized her spending for the month into 4 categories. Okay? The word problem says, what percent of her total spending did she spend on food? What percent? We don't know. We only know the amounts, exact amounts on food. Food. She spent $378 out of her total. And we want to turn that into a percent. First, I would turn it into a decimal, and then I would turn it into a percent. What is the total? So you need to add those 4 things up. 378, 472, 283, 567. Because you're looking for the portion out of the total. Okay? So you have to add those up. Make sure you do that. Then you do that division, and then you turn that division answer, decimal answer, into a percent. Again, I'm just going to leave this here for you to take a look at. This is part of the practice test, so I'll let you finish it. Joyce paid $44 for an item at the store that was 60% off the original price. What was the original price? Okay. If it was 60% off, what did she pay? If it's 60%, that much of the price was cut off. Here's my scissors. All right, I'm going to cut that price off. All right. That means she's paying 40%. 40% of the original price is her new price. 40% she's paying. 40%, we don't know the original price, that's our N, but we know what she paid. So 0.40 times a number equals $44. To find N, algebraically, we say let's divide both sides of our equation by 0.40. Gets rid of my 0.40, and my answer then is whatever you get here. So see that 60% off, that was the price that that's on sale for. That would draw people in. 60% off today. That's great. What are you paying? You're paying 40%. 40% of the original price is what you're going to pay. New price, how much you're going to pay. and that's how it set up that problem. Again, I'll let you finish that. Just want to help you set up a few of these and understand how to set them up, because I just want you to have that familiarity, okay? And I think that's all I want to say for now. I know this dragged on really, really long. My apologies, but I wanted to cover some things with you. I'm going to make another video on the next unit, because again, now we're getting into some more complicated math, and I just want to make sure that I'm giving you my perspective as well as having the James Souza videos to rely on, because they are awesome. I really think those are great videos, but I just wanted to add my 2 cents here. So if you are doing the teach back lessons and you happen to get 0 points on that or 1 point, you can redo it, okay? But for the most part, I think everyone's doing really well with those. It's really exciting. I like that many of you have learned how to submit those on Canvas. That's really cool for me because it makes it very easy to grade and record those grades, okay? If you have any question on the grading system that I'm trying to implement in Canvas, please let me know. But pretty much I'm just trying to put the mechanics of it together. Nothing is changing as far as the syllabus goes, as far as the percentages are. They're all the same. I just wanted to make sure that you understood some of that information and what's going on with the Canvas this last week and next week, this week. Okay, all right. Have a good week, everyone. Okay, bye-bye.